When you say something is far away, you almost always mean a distance you could cross. A long drive, a flight to the other side of the world, a gap that closes if you are patient enough and keep moving toward it. That is what far has meant for your entire life. But there is a place so far away that the word breaks in your hands. Its light took more than 13 billion years to reach us, which means it left before the sun existed, before the earth existed, before the atoms in your body were ever forged. And here is the part that word never prepared you for. That place is not 13 billion light years away. It is more than 33 billion, carried off by the expansion of space itself, receding faster than light can follow, its presence sealed away from us forever. Get comfortable and settle in. Hit subscribe if you are new here, because by the end of this, the word far is going to mean something colder and stranger than it ever has before. Now, let's slowly ease into this. Part 1. The faint orange point. There is a place so far away that you can hardly hold it in your mind. I know I say that often, in different ways, but this time I mean it in the most literal way possible. This is the single most distant place that human beings have ever confirmed. And when you finally see it, it looks like almost nothing at all. In the image, it is a small orange shimmer sitting among thousands of other points of light. If nobody told you, you would slide right past it. You might even mistake it for a flaw in the sensor, a stray speck, a pixel that misfired. But this one point is not a flaw, and it is not like the others around it. The light gathered in that faint smudge began its journey before the earth existed. It began before the sun existed. It began before almost everything you have ever known or touched or been made of had come into being. That light travelled for more than 13 billion years to reach the mirror that caught it. More than 13 billion years, crossing an emptiness with no landmarks, no shores, no halfway signs, until it finally ended its trip inside a telescope built by a species that would not appear until the journey was almost over. Think about the sheer patience of that journey. When this light set out, there was no Earth for it to aim at, no sun, no solar system, not even the raw cloud of gas that would one day collapse to form them. Our entire world was not late to the appointment. It simply did not exist, and would not exist for more than 8 billion years after the light began travelling. The light crossed a universe that had to build our planet from scratch while the beam was still in transit, and it kept coming the whole time, indifferent to whether anything would ever be waiting at the far end to notice it. There is a kind of accidental grace in that. A signal was released into the dark, with no destination, and by the slimmest of chances, an eye was assembled in its path, at just the right moment, in just the right place, tuned to just the right wavelength, to catch it as it arrived. Change any part of that story, delay our species by a cosmic eye blink, aim the telescope a fraction of a degree away, and the light would have passed us by and continued on into the emptiness, unseen, forever. When you look at that point, you are not simply looking at something distant, you are looking at something old. You are looking at a moment that happened when the universe itself was practically newborn. Let me put that number where you can feel it. The universe today is a little under 14 billion years old. The light from this place left its source when the universe was only about 290 million years old. That is roughly 2% of all the time that has passed since the beginning. 2%. If you compress the entire history of the cosmos into a single year, this light set out in the first few days of January, and it has been travelling ever since, all the way to this exact moment when it finally arrived and we noticed. The place has a name, though calling it a name is generous. It is labelled JADES, GSZ 140. It sounds like a password, or a serial number stamped on the underside of a machine. And in a sense, that is exactly what it is. It is a catalogue entry. The letters mark the survey that found it and the patch of sky it lives in. The number 14 encodes just how far its light has been stretched on the way here. But underneath that cold string of characters is a real place, a real galaxy, full of real stars, burning in a corner of the early universe that no human eye will ever visit. I want to dwell on the image itself for a moment, because there is something almost comic about how ordinary it looks. When the picture was released, people expecting a grand swirl of colour, the kind of poster-ready spiral you might hang on a wall, found instead a nearly featureless reddish dot, so faint and so small that it had to be circled and pulled out into a magnified box, just so anyone could tell which speck was the historic one. That is the honest face of the farthest place we know. It does not announce itself. It does not glow with menace or grandeur. It is the quietest thing in a frame full of quiet things, and only the physics reveals that it is also the most extraordinary. There is a lesson buried in that, one the universe teaches over and over. The most profound things are rarely the loudest. Sometimes the entire early history of the cosmos is hiding in a smudge you would have wiped off the lens. Consider, too, what it took for that smudge to reach you as anything at all. The light gathered there is almost unimaginably faint, spread so thin by its enormous journey that only a handful of its particles arrive from that direction in any reasonable span of time. Catching them is less like taking a photograph and more like standing in a field on a still night, trying to notice a single snowflake landing on your outstretched hand once every few minutes, and from those rare, scattered arrivals, reconstructing an entire storm that fell before you were born. That is the delicacy of what we are doing when we look this far. We are not flooded with information. We are straining to hear the faintest possible signal against the silence, and the fact that any signal survives the trip at all is its own small miracle. And this is only the surface of the strangeness, because the moment you accept that the faint dot is real and old and unreachable, a series of questions begins to open beneath it like a stairway going down into the dark. How can we possibly know its distance? What was it actually like? Why does it sit so much farther away now than the number 13 billion suggests? And, most unsettling of all, what has become of it in the enormous span of time since the picture we hold was taken? We will walk down every one of those steps tonight, slowly, one at a time, but all of them begin here with a single faint orange point that most people would never have looked at twice. And here is the first strange thing, the first small crack in how you probably think about the sky. When you look up at night, you tend to imagine you are seeing the universe as it is. You are not. You are seeing a collage of different times, all pretending to be the same instant. The moon you see is a little more than 1 second old. The sun, if you dared to look, is about 8 minutes into your past. The nearest stars are years behind. And this faint orange point is 13 billion years behind. A single frame from a time that no longer exists, delivered to your eyes as though it were happening now. I want you to sit with that idea, because everything else we talk about tonight grows out of it. That point of light is not a picture of where the universe is going. It is a message from where it began. And the closer we look at it, the stranger, and, in a quiet way, the more unsettling it becomes. Because this is not just the oldest thing we can see. It is a place that raises a question most of us never think to ask. If we are seeing it as it was more than 13 billion years ago, then what is it now? Where is it now? And why is it that the answer to those simple questions is something we may never be allowed to know? To get there, we have to start with the one word that hides all the mystery in plain sight. The word is far, and it does not mean what you think it means. Part 2. What far really means. When people say something is far away, they usually mean a drive A few hours on a highway, maybe a flight to another continent in the worst case. Far, in ordinary life, is a distance you could cross if you were patient and had enough fuel. It is a gap that closes if you simply keep moving toward it. That is the entire meaning of the word for almost everything you will ever do. In the universe, far means something else entirely, and the shift happens faster than you expect. Step off the Earth. And the first truly far thing is the nearest star system to our own, Alpha Centauri. It sits a little more than 4 light-years away. That already sounds manageable, 4 of something, until you understand what a light-year actually is. It is not a measure of time, even though it sounds like one. It is a distance. It is how far light travels in a single year, moving at the fastest speed anything can move. And that distance comes out to about 9.5 trillion kilometers. 4 of those, stacked end to end, is the gap to our nearest neighbor. To cross that gap with the fastest spacecraft human beings have ever built would take on the order of tens of thousands of years. Not a lifetime, not a few generations. Longer than all of recorded history, several times over, just to reach the closest star. And that star is, on the scale of the universe, practically leaning against our shoulder. It is the next house on the street. We have not even left the neighborhood. It helps to build the ladder one rung at a time, because the human mind does not naturally handle these jumps. We are built to understand the distance to the next hill, maybe the next town. We are not built to feel the difference between 1,000,000 and 1,000,000,000, even though one is 1,000 times the other. So let us climb slowly. Light leaves the moon and reaches your eye in a little over a second. Light leaves the sun and takes about 8 minutes, which means if the sun quietly went out, you would carry on in full daylight for 8 minutes before the darkness arrived, unaware that the source was already gone. The nearest planets are minutes to hours away in light. The outer edge of our own solar system, where the last of the sun's influence fades, is many hours of light travel from here. Already, at the scale of a single star system, the delays are longer than a working day. Then comes the leap to the stars, and the unit itself has to change from minutes and hours to years, because nothing smaller will do. And, once you are counting in light years, you have quietly crossed a threshold. Every distance is now also a duration. There is no longer any such thing as seeing a star as it is. There is only seeing it as it was some number of years ago, the number growing with the distance. The night sky, which looks so still and so present, is actually a layered thing, each point of light showing a different depth of time. The nearer stars a few years back, the farther ones centuries or millennia back, all of it arriving together and pretending to be tonight. Keep climbing, and the numbers stop being counts you can picture and start being labels you simply have to trust. Our galaxy is about 100,000 light-years across. If you could somehow stand above it and watch light crawl from one edge to the other, you would wait 100,000 years for the crossing, and in that time our entire species, from the first anatomically modern humans to now, would rise and live and wonder, all while a single beam made its way across our one galaxy. That is the size of the room we live in, and it is only one room among perhaps 2 trillion in the observable universe. The mind wants to round these numbers off, to treat 100,000 and 1,000,000,000 as both just very big. But the whole meaning of tonight lives in the difference between them, so we have to resist the rounding and let each jump land as its own separate shock. Now here is where the word far quietly changes into something stranger. A light year is a distance, yes, but because light takes time to travel, that distance is also a look backward in time. When you glance at Alpha Centauri tonight, you are not seeing it as it is. You are seeing light that left it 4 years ago. If something dramatic happened there this evening, you would not find out for another 4 years, because that news, carried by light, is still on its way. The star you see is a memory. A recent memory, but a memory all the same. The further away something sits, the deeper into the past you are looking. This is not a trick or a figure of speech. It is the literal, physical situation you are in every time you look up. Our own galaxy, the Milky Way, is about 100,000 light-years across. That means the light from stars on the far side of it left before human civilization existed, before agriculture, before the first cities. When you look toward the other edge of your own galaxy, you are looking tens of thousands of years into the past, and you cannot do otherwise. There is no setting on any telescope that shows you the galaxy as it is right now. That view does not exist for us. It cannot. And here is a detail that makes the Milky Way's size personal rather than abstract. The light you see from the far side of our own galaxy, left before the pyramids, before writing, before farming, tens of thousands of years of human striving have unfolded in the time it took that light to cross a single galaxy. Our galaxy, the one we call home and think of as a single place. We do not experience our galaxy as a spread of different times, because we cannot see it change on human timescales. But it is one. Every direction you look within it, you are seeing a slightly different slice of the past. The near stars almost current, the distant ones far back in history, all stitched together into what looks like a single, tranquil scene. Home itself is already a patchwork of moments, and we simply never notice. Push further. The nearest large galaxy beyond our own is Andromeda, about 2.5 million light-years away. It is the most distant thing most people can see with their unaided eyes, a faint smudge on a dark night. The light entering your eye from Andromeda left it 2.5 million years ago, when our ancestors were not yet what we would call human. You are, quite literally, looking at a galaxy as it appeared before your species existed. And it is still one of our closest cosmic companions. So by the time we talk about a place whose light has travelled for more than 13 billion years, the ordinary meaning of far has completely dissolved. You are no longer looking across a distance you could ever hope to cross. You are looking into a time you could never reach, at an object that has spent longer sending you this one image than the Earth has spent existing. Distance and time have run together into a single thing, and you cannot separate them anymore. To look out is to look back. There is no other way to see. That is the rule that governs everything from here on. You are not looking into the distance. You are looking into the past. Hold on to that sentence, because we are going to return to it more than once tonight, and each time it is going to mean a little more than it did before. For now, just let it settle. The most distant place we know is also, by the same measurement, the oldest thing we can see. And the tool that let us see it had to be one of the strangest machines our species has ever flung into the dark. Part 3. The machine built to see the invisible. None of this would be possible without a very particular telescope, and it is worth understanding why an ordinary one would have failed completely. The telescope that found this place is the James Webb Space Telescope, and it does not see the universe the way your eyes do. It was designed, from the ground up, to catch light that human eyes cannot detect at all. To understand why that matters, you have to understand what the expansion of the universe does to light on a long enough journey. Space itself is stretching. Not the galaxies moving through space like debris drifting apart, but the space between them growing, swelling, lengthening in every direction at once. And light that travels through that expanding space gets stretched along with it. A wave of light that started out short and energetic, the kind our eyes would read as blue or even ultraviolet, slowly gets pulled longer and longer as it crosses billions of years of swelling space. By the time it arrives, it has been dragged all the way down into the infrared, into wavelengths our eyes simply cannot register. The further the light has travelled, the more severe this stretching becomes. For a place as distant as the one we are talking about, the stretching is extreme. The light that left it as brilliant ultraviolet the fierce glow of young stars, arrives at us shifted so far down the spectrum that an ordinary optical telescope would see nothing there at all, just darkness. The galaxy would be sitting right in the frame, and a normal telescope would report empty space because the light is real but has moved into a range those instruments were never built to catch. This is why the James Webb Telescope observes in the infrared. It was made specifically to catch this ancient, stretched, exhausted light, the light that has been on the road so long it has changed colour entirely. And to catch light this faint, coming from this far, it also needed to be enormous. Its main mirror is about 6.5 meters across, built from 18 gold-coated segments that unfolded in space like a flower opening. That gives it something on the order of 6 times the light-gathering area of the older Hubble telescope. When you are trying to collect a signal this weak, a signal that has spread thin across 13 billion years, every extra bit of mirror matters. It is the difference between seeing the object and never knowing it was there. The mirror is not just large, it is a work of strange and specific art. Rather than a single sheet of glass, it is built from 18 separate hexagonal segments, fitted together into one honeycomb surface and coated in a microscopically thin layer of gold, because gold happens to reflect infrared light with unusual efficiency. Each of those segments can be nudged and tilted by tiny motors, adjusting its position by amounts smaller than a fraction of the width of a human hair, so that all 18 pieces act together as a single flawless mirror. To catch light this faint, the surface has to be shaped to a precision that staggers the imagination, smoothed to within a tiny fraction of the wavelength of the light it is collecting. If that mirror were scaled up to the width of a continent, its largest bumps would be no taller than a few inches. That is the level of care required to gather a signal that has spent 13 billion years thinning out across the growing dark. The telescope does not sit in orbit close to Earth the way many satellites do. It rests far out, about 1 million miles away from us, in a cold and stable spot where it can stare into the darkness without the Earth or the Sun ruining its view. It has a shield the size of a tennis court that keeps sunlight off the delicate instruments, letting them cool to temperatures barely above absolute zero because warmth itself glows in the infrared, and a warm telescope trying to see infrared light would be blinded by its own heat. This is one of those details that sounds like a technicality, but is actually a profound constraint. Any warm object gives off infrared light simply by being warm. Your own body is glowing in the infrared right now, which is how night vision devices see you in the dark. So a telescope built to detect the faint infrared whisper of the first galaxies cannot itself be warm, or its own glow would drown out everything it was trying to see. It would be like trying to hear a pin drop while shouting. The entire far side of the telescope, the science side, therefore has to be kept colder than almost anywhere in the natural solar system, shielded from the sun, from the earth, and even from the warmth of its own electronics, chilled down to within a few degrees of the coldest temperature that physics allows. Only in that deliberate, engineered cold can it fall silent enough to hear the ancient light. There is a poetry in that, if you look for it. To see the fiery birth of the first galaxies, we had to build the coldest, quietest, most patient eye we could, and carry it to a still point far from the warmth of home, and let it grow silent and frigid in the dark, so that it could finally listen for the faintest arriving trace of the universe's first fires. The hottest story in the cosmos could only be read by the coldest instrument we ever made. And it worked. Against every obstacle, the cold eye opened, steadied itself, and caught the light it was built to find. That is the machine that turned a faint reddish smudge into the most distant, confirmed place in the known universe. And it did so by being patient and cold and quiet in exactly the ways the light required. Everything about the machine is a solution to a single problem. How do you see something so faint, so stretched, and so far that it is almost not there at all? It is worth pausing on just how counterintuitive the infrared trick really is, because it inverts something you feel you understand. We think of distant things as looking bluish or white, or simply dim, the way a far-off streetlight does. But the early universe hands us the opposite. The hottest, bluest, most violent light imaginable, the ultraviolet glare of enormous young stars, is precisely what arrives at us as gentle, invisible, infrared warmth, because the journey has stretched it so far. The fiercest light in the cosmos reaches us disguised as the mildest. If you had eyes that could see infrared, this galaxy would not look like a hot blue furnace at all. It would look like a faint red ember, cooled by distance, its true ferocity hidden inside the long wavelengths that 13 billion years of stretching have imposed on it. The telescope is not just seeing far, it is translating, taking a language our eyes cannot read and rendering it into something we can measure. There is also a quiet fragility to the whole enterprise that I find moving. This telescope cannot be repaired. It sits too far away for any human being to reach, out at that cold and stable point, roughly 1 million miles from Earth, and if something had gone wrong during its unfolding, there would have been no rescue, no service mission, nothing to do but mourn. Its mirror had to open perfectly, its shield had to deploy perfectly, its instruments had to cool and align perfectly, all of it automatically, all of it alone in the dark, with the whole endeavour of seeing the first galaxies riding on the outcome. That it worked at all is a small triumph of patience and care. And the reward for that care was the ability to catch a whisper of light that had been travelling since before the sun, and to hold it steady long enough to learn what it was. But even a perfect machine, catching a perfect faint signal, still faces the hardest question of all. Seeing a dot is not the same as knowing its distance. A faint red point could be a nearby failure of a star, small and cool and close, merely pretending to be ancient. It could be a middling galaxy at a middling distance, reddened by dust rather than by the stretching of space. The image alone cannot tell you. You need to make the light testify. You need to force it to reveal not just that it is there, but how far it has come and how long it has been coming. And for that, you stop taking pictures and start doing something closer to chemistry. But seeing a faint smudge is only half the job, and honestly, it is the easier half. A faint reddish dot could be many things. It could be a small, cool star inside our own galaxy, close and dim, that only looks distant. It could be a nearer galaxy, playing tricks with its colour. Simply spotting a point of light tells you almost nothing about how far away it is. You need a second step, a way to force the light to confess its true distance. And that step is where the real detective work happens. That is where a faint orange smudge finally admits that it is the most distant confirmed place in the known universe. Part 4. Reading the fingerprint. Here is the question that sounds impossible when you first hear it. How can anyone possibly know that a single point of light is 13 billion years away, rather than 1 billion, or 3, or 20? You cannot pace it out. You cannot bounce a signal off it and wait for the return, because the return would take twice the age of the universe. And yet we can measure this distance, and measure it well, and the way we do it is one of the quietly beautiful facts of physics. Every chemical element leaves a signature in light. When you spread a beam of light out into its full range of colours, the way a prism spreads sunlight into a rainbow, you do not always get a smooth, unbroken band. Instead, you see specific bright lines and specific dark gaps sitting at exact positions. Those positions are set by the elements present in and around the source. Hydrogen makes its marks at certain places. Oxygen makes its marks at others. Each element has its own precise pattern, always the same, as reliable as a fingerprint. Spread out the light of any glowing thing in the universe, and you can read which elements it holds by where those lines fall. Now here is the crucial part. Because the expansion of the universe stretches light on its way to us, it stretches these fingerprint lines too. The whole pattern slides toward the red and infrared end of the spectrum, and it slides by a very specific amount. The elements are still recognizable. The pattern is still there, still in the same relative arrangement, so you can tell it is hydrogen or oxygen or whatever it happens to be. But the entire fingerprint has been shifted, bodily, toward longer wavelengths. And the amount of that shift tells you exactly how much the universe has expanded since that light set out, which tells you, in turn, how long the light has been traveling and therefore how far away the source truly is. Astronomers call this shift the redshift, and they give it a number. For the place we are discussing, that number is about 14.3. That is an enormous shift. It means the light has been stretched by a factor of more than 15 since it left. Ultraviolet became infrared. The fingerprint slid so far down the spectrum that only an infrared telescope could ever have read it. And that single number, 14.3, is what crowns this galaxy as the most distant confirmed place we know. The number in its catalogue name, the 14 in JADESGSZ140, is that very redshift, written into its label like a birth certificate. Let me make sure the logic of this is solid in your mind, because it is the foundation everything else rests on, and it is genuinely one of the most elegant ideas in science. The reason redshift works as a distance measure is that the stretching of light is not random. It is tied directly to how much the universe has expanded during the light's journey. A little expansion, a little stretch. An enormous expansion, an enormous stretch. So when we measure how far the fingerprint has slid, we are really measuring how much bigger the universe has grown since that light set out. And because we understand, from many independent lines of evidence, how the expansion of the universe has proceeded over time, we can convert that stretch into an age and a distance with real confidence. The light is carrying, encoded in its own reddening, a record of everything that happened to the space it crossed. It is a ruler and a clock at once, and we only had to learn how to read it. There is a particular feature in the light that makes this especially clean at extreme distances, and it is worth naming because it is what actually seals these measurements. In the early universe, space was filled with neutral hydrogen gas, and that gas is very good at absorbing light beyond a certain wavelength. So when you look at the spectrum of an extremely distant galaxy, you find a sharp cliff, a place where the light abruptly drops away to nothing on one side. Below that edge, the hydrogen has swallowed everything. Above it, the light comes through. That cliff is called the break, and its position is like a mile marker. Because we know exactly what wavelength the break sits at when it is emitted, we can see how far it has been shifted by the time it reaches us, and from that shift, read the distance. It is a wonderfully unambiguous signal. You are not squinting at a subtle tint. You are seeing a clean edge, a definite line in the light, and measuring how far the universe has dragged it. I want you to picture how this confirmation actually happened, because it was not instant, and it was not casual. The telescope had already caught the faint smudge in its images, and the smudge looked promising, the kind of reddish point that might be extraordinarily distant. But might is not knowledge. To be certain, the astronomers pointed the spectrograph at that one dim speck and held it there. They stared at it for nearly 10 hours, gathering every scrap of stretched light it would give, slowly building up the spectrum piece by faint piece. There is a real human drama in those 10 hours that is easy to miss under the tidy language of a result. Telescope time on an instrument like this is among the most precious and contested resources in all of science. Every hour is fought over, scheduled far in advance, justified against 100 competing dreams. To spend nearly 10 of those hours staring at a single faint smudge is a genuine gamble, a bet that this particular dot is worth more than everything else you could have pointed at instead. The astronomers made that bet on the strength of an image and a hope, and they had to wait through the whole long exposure, not knowing whether they had caught the most distant galaxy ever confirmed or simply wasted an irreplaceable stretch of the world's finest eye on a nearer, duller object wearing a convincing disguise. The confirmation, when it came, was not just a data point. It was the resolution of a held breath, and then the pattern emerged. There was a sharp cut-off in the light, a clean edge, below which the galaxy simply went dark, exactly the feature you would expect from hydrogen in the early universe, absorbing everything past a certain wavelength. And that edge sat precisely where a redshift of about 14 would put it, not close. Precisely there. In that moment, a possibility became a measurement. A hopeful smudge became a confirmed record. The most distant place anyone had ever pinned down, its distance no longer a guess, but a fact written in the physics of its own light. The result was published and announced to the world, and for a while, this faint orange point held the title of the farthest thing humanity had ever confirmed. It is worth appreciating that this method of reading distance from light is not some fragile, one-off trick used only for this galaxy. It is the same fundamental technique that underlies our entire map of the cosmos. Every large-scale distance in astronomy, every claim about how far away a galaxy sits, or how long ago its light set out, ultimately rests on measuring how the light has been shifted and stretched. We have cross-checked it against other methods wherever we can, against the brightness of certain exploding stars that always detonate with nearly the same intrinsic power, against the subtle patterns imprinted on the oldest light in the universe. And it all fits together into a single, consistent picture of an expanding cosmos. So when we say this galaxy is 13.5 billion years into the past, we are not guessing, and we are not relying on a lone measurement that could easily be wrong. We're applying a tool tested across countless objects, at countless distances, refined over a century of careful work, to one particularly faint and particularly ancient point of light. Think about what that confirmation really contains. It is not a photograph in the ordinary sense. It is the arrival of a signal that left before the sun, carrying inside it the chemical fingerprint of a galaxy that has been gone from that state for longer than our planet has existed. We did not travel to it. We could never travel to it. We simply waited with the right machine, in the right cold and distant place, and caught the faintest possible whisper of it as it finally washed up on our shore. And once we had, the next question arrived on its own, unbidden and a little dizzying. If this is what the place looked like, then what, exactly, were we looking at? What kind of world burns at the very dawn of everything? Part 5. Standing in the Young Universe. Let me take you there, as much as words can. Imagine, for a moment, that you could stand somewhere inside this galaxy at the very moment its light set out, 290 million years after the beginning. What would be around you? What would the sky look like? We cannot know every detail, but physics lets us sketch the scene with real confidence, and the scene is nothing like the calm night you know. The first thing you would notice is that the sky is crowded. In the early universe, everything was closer together. Expansion had not yet had time to push the galaxies far apart, so they hung near one another, packed into a smaller space. Where our night sky is mostly darkness with scattered points of light, this sky would be busy, filled with more galaxies, closer, brighter, more of them in every direction you turned. It would feel less like standing in an empty field at night and more like standing in a room full of distant fires, the whole sky faintly aglow with company. Try to feel the difference in your body, not just your mind. The night sky, you know, is mostly black, a wide darkness with a scattering of lights, and, on a good night, the faint band of our own galaxy arching over you. It is a spacious, empty-feeling sky, and that emptiness is a product of age. The universe has had almost 14 billion years to spread out, to push its galaxies apart, to open enormous gulfs of nothing between the islands of light. But at the moment we are visiting, the universe is young and small, and has not yet done most of that spreading. So the sky is close, the other galaxies press in. Instead of a scattering of distant sparks, you would stand under a canopy of nearer fires, the whole dome of the sky faintly luminous, with the crowded company of a cosmos that has not yet learned how to be lonely. The stars themselves would be wrong by our standards, and wrong in a way that is beautiful and violent at once. The universe back then had almost no heavy elements. In the beginning, there was essentially only hydrogen and helium, the two lightest elements, the only ones the Big Bang itself produced in quantity. Everything heavier, the carbon in your cells, the oxygen you are breathing, the iron in your blood and in the ground beneath you, none of it existed yet. All of those elements have to be forged inside stars and then scattered outward when those stars explode. And at this early moment, only the very first waves of stars had begun that work. Stars built from almost pure hydrogen and helium behave differently than the Sun. They tend to grow enormous, far more massive than our star, burning ferociously hot and blindingly bright. They are blue-white, savage, and short-lived, racing through their fuel in only a few million years before tearing themselves apart in tremendous explosions. So the stars around you would not be the steady, patient suns you are used to. They would be giants, blazing and doomed, some of them poised to detonate on a timescale that is almost instant by cosmic reckoning. You would be standing in a nursery and a battlefield at the same time, where things are being born massive and dying young all around you. There is a strange intimacy in realizing that these violent early stars are the reason you exist. Every heavy atom in your body, the calcium in your bones, the iron carrying oxygen through your blood, the oxygen itself, was forged inside a star and released when that star died. But the very first stars had none of that to work with. They were the first furnaces, built from the plain hydrogen and helium of the beginning, and they had to make the heavy elements from nothing but those raw ingredients, then dye and scatter them so that later stars and later worlds, and eventually you, could be built from the debris. When you stand in this young galaxy and watch a massive blue star tear itself apart, you are not just watching a distant catastrophe. You are watching the opening act of the process that leads, across billions of years, to the atoms of your own hand. These are not just any stars. They are among the first cooks in a kitchen that would eventually prepare everything. The space between the stars would not be clean, either. Gas and dust would drift everywhere, the raw material of a universe still assembling itself, still figuring out how to make the structures we take for granted. There would be no tidy solar systems like ours, no calm arrangements of rocky planets circling a mild star. It would be turbulent, unfinished, in motion. The universe was not resting here, it was working. And there is one more thing, subtle and strange, filling the whole sky at once. The afterglow of the Big Bang, the faint background of ancient light that still fills all of space today, was warmer then. In our era, that background sits at only a few degrees above absolute zero, far too cold to feel. But at this early moment, it was warmer, around 42 degrees on the absolute scale, present everywhere, in every direction, a gentle uniform warmth soaked into the fabric of space itself. You would not see it as a glow exactly. It would simply be there, an even pressure of leftover heat from the birth of everything, wrapping the entire young cosmos in the fading warmth of its own beginning. There is something worth sitting with in that image of the warm background, because it connects the largest thing to the most intimate. That leftover heat from the birth of the universe is not a metaphor and not gone. It is still here, right now, all around you, having cooled over billions of years from that early warmth down to the faint chill it holds today. The same background that would have wrapped you in gentle warmth in the young galaxy is, in our era, the coldest and oldest light there is, arriving from every direction at once. When engineers first stumbled on it, they thought it was noise in their equipment, a hiss they could not get rid of. It turned out to be the fading warmth of creation itself, filling all of space, a faint uniform glow left over from the moment the universe first became clear enough for light to travel freely. In the young galaxy, that glow was close and warm. Here, it is distant and cold. But it is the same light, the same afterglow, stretched and cooled by the very same expansion that reddened our orange point. Everything tonight keeps circling back to that single fact. The universe stretches, and the stretching changes everything it touches, from the color of a galaxy to the temperature of the sky itself. And the pace of everything would be faster and fiercer than anything in our calm modern sky. In our era, a star like the Sun lives for roughly 10 billion years, a steady lamp that outlasts civilizations without any visible change. But the giant stars of the early universe measured their lives in mere millions of years, sometimes just a few, racing through their enormous fuel supplies and then detonating. If you could somehow watch this young galaxy on fast forward, it would not look serene at all. It would flicker and flash with the births and deaths of stars, one great blue giant after another, igniting, blazing, and blowing itself apart. Each explosion seeding the surrounding gas with fresh, heavy elements and triggering the collapse of new stars nearby. It would look less like the quiet night we know and more like a furnace being stoked, a place where the raw material of everything to come was being cooked and scattered and cooked again, at a tempo the modern universe has long since left behind. This is the place whose light we caught. Not a barren, empty, frozen dawn, but a hot, crowded, turbulent, living furnace of creation, actively making the first heavy elements that would one day become planets and oceans and us. When you look at that faint orange point, this is the scene folded up inside it, and that alone would be enough to sit with for a long night. But the strangest thing about this place is not what it was. The strangest thing is that it should not have looked as grown up as it did. Part 6. The thing that should not be there. For all the wonder of simply seeing this place, the discovery came with a genuine shock, the kind of shock that sends physicists back to their models with a frown. The galaxy was not supposed to look like this, not this early, not this soon after the beginning. Remember where we are in cosmic time. 290 million years after the Big Bang is, by every standard model of how galaxies form, absurdly early. At this stage, galaxies were expected to be small, faint, and simple, barely more than loose gatherings of the first stars, made of little but hydrogen and helium, only just beginning the long, slow work of assembling into anything substantial. That was the prediction. That was the tidy timeline. Small, dim, primitive, and just getting started. Instead, this galaxy is large. It stretches more than 1,600 light-years across, which is far too big and far too spread out to be the light of a single bright object hiding at its center. The glow has to be coming from many stars distributed throughout it, which means it is already a substantial, functioning galaxy, not a tiny seed. And it is luminous, genuinely, intrinsically bright, far brighter than the early models said anything could be at this age. It is, in short, too much, too soon. Then came the detail that turned a surprise into a real puzzle. Astronomers using a different observatory, a great array of dishes high in the Chilean desert, went looking for the fingerprint of oxygen in this galaxy. Oxygen, remember, is a heavy element. It does not come from the Big Bang. It can only be built inside stars and then flung out into space when those stars die. To find oxygen in a galaxy is to find proof that entire generations of stars have already lived, burned, and died there seeding their surroundings with the ashes of their own furnaces. They found it, and they found much more of it than anyone expected, something like 10 times more heavy elements than the models predicted for a galaxy this young. One of the lead scientists described it in a way that stays with you. He said it was like finding an adolescent to where you would only expect to find babies. Let me make sure that comparison lands, because it is doing a lot of quiet work. When we say a galaxy is chemically young, we mean it is still made almost entirely of the light elements left over from the beginning, with barely any of the heavier stuff mixed in yet, because there has not been enough time for stars to make it. When we say a galaxy is chemically mature, we mean the opposite. We mean it has already run through cycle after cycle of stars being born, burning through their fuel, and dying in explosions that scatter freshly made heavy elements into the surrounding gas, so that the next generation of stars forms from richer material than the last. Maturity, in this sense, is not about size. It is about how many rounds of birth and death the galaxy has already been through. And a galaxy at 290 million years should have had time for only the very first round, if that. To find it already stocked with the debris of many rounds is genuinely strange. It is as though you opened a door onto the very first morning of the world and found, waiting inside, something that had clearly already lived through many long days. This galaxy, seen at the very dawn of cosmic time, was already chemically grown up. It had already run through cycles of star birth and star death fast enough to enrich itself with the leftovers, and it had done it in a window of time that our theories said was far too short for such maturity. And this is not a lone oddity that we can quietly set aside. Since our orange point took its brief turn as the record holder, the frontier has already moved again, and the pattern only sharpened. Since then, an even more distant galaxy has been confirmed, its light stretched even further, seen even earlier, only about 280 million years after the beginning. That one, too, is compact, luminous, and chemically peculiar, showing signs of enrichment that should take much longer to develop than the time available. It is remarkably tight and bright, packing a tremendous amount of light into a space only a couple of hundred light-years across, and it carries a chemical signature that looks less like a raw newborn galaxy and more like the dense, processed cores we associate with much later, more evolved environments. In other words, the new champion is, if anything, an even sharper version of the same puzzle. It is not just far, it is far and early and already carrying the marks of a history it should not have had time to accumulate. And notice what the very existence of these repeated records is telling us, almost as loudly as the records themselves. The title of most distant place is not a fixed landmark. It is a moving line, pushed outward every year or two as our instruments improve and our surveys reach a little deeper into the faint infrared. Each new record holder is crowned, studied, and then quietly dethroned by something farther still, which means that the specific galaxy we are focused on tonight is best understood not as the actual edge of what exists, but as the current high watermark of what we have managed to confirm. The real most distant place is always a little beyond the last one we found, and always will be, right up until we hit the true limit of what light and time will allow us to see. The record for the most distant place keeps moving outward, and each new record holder tells the same unsettling story. These early galaxies are brighter, bigger, and more mature than they have any right to be. In fact, we now find far more of these bright early galaxies than the models ever allowed, more than 100 times as many as we expected to exist at all. It is worth being honest about how science reacts to a result like this, because the reaction is itself revealing. The natural first instinct is doubt. When a measurement contradicts a well-tested model, the responsible move is not to throw out the model immediately, but to interrogate the measurement. Maybe the distance is wrong. Maybe the brightness was overestimated. maybe some nearer object is contaminating the light. So astronomers pushed on every part of it, checked and rechecked, brought in independent instruments, and looked for any ordinary explanation that would let the old timeline stand. And the anomaly survived that scrutiny. The distance held up under spectroscopy. The brightness held up. The chemical maturity was confirmed by a completely separate observatory using a completely different method. That is what makes this unsettling rather than merely surprising. It is not a single shaky data point that a careful skeptic can wave away. It is a growing pile of well-checked results, all pointing the same uncomfortable direction, all saying that the early universe built things faster than we thought possible. None of this breaks physics. Let me be clear about that, because the channel is not in the business of pretending the sky is falling. The expansion of the universe, the age of the cosmos, the redshift measurements, all of that stands on firm ground, cross-checked many different ways. What is breaking, or at least bending badly, is our story of how quickly the universe learned to build things. We thought the first galaxies would need a long, slow childhood. Instead, they seem to have grown up almost overnight, cosmically speaking, assembling and maturing while the universe was still, by any measure, an infant. The furthest places we can see are not just old. They are precociously, inexplicably advanced, and they are quietly forcing us to rewrite the opening chapter of the entire story. But even that mystery is not the one the title promised you. The truly vertiginous part is not what this place was. It is where it is now, and to understand that, we have to confront a number that seems, at first, to make no sense at all. Part 7. The distance that is not the distance. Here is a fact that sounds like a mistake when you first hear it, and I want to walk through it slowly because it is the hinge on which everything turns. The light from this galaxy took more than 13 billion years to reach us. And yet, right now, the galaxy is not 13 billion light-years away. It is more than 33 billion light-years away. Both of those numbers are true at the same time. And once you understand how they can both be true, the universe stops feeling like a fixed room you are standing in and starts feeling like something far stranger. Start with the assumption almost everyone makes, the one that feels like plain common sense. If the light took 13 billion years to get here, then surely the source must be 13 billion light-years away. That is how it would work for anything moving at a fixed speed across a fixed distance. Light travels at a steady speed. It travelled for 13 billion years, so it must have covered 13 billion light-years. Simple. And completely wrong, because it quietly assumes that the distance stayed the same during the trip. It did not. The universe is expanding. Space itself is growing, everywhere, all the time. This is not galaxies flying apart through some fixed, unchanging space, like fragments from an explosion moving through an empty room. It is the room itself getting bigger. The space between things is being created, stretched, added to continuously. And that changes everything about what distance even means over a journey this long. This is the single hardest idea to hold, so let me give you a picture for it that physicists themselves use. Imagine a loaf of raisin bread rising in the oven. The raisins are the galaxies, and the dough is space. As the dough rises, every raisin moves away from every other raisin, not because the raisins are crawling through the dough, but because the dough between them is expanding. A raisin near you drifts away slowly. A raisin on the far side of the loaf drifts away much faster, because there is so much more dough between you and it, and all of that dough is swelling at once. No raisin is special. From every raisin's point of view, all the others are receding, and the farther ones recede faster. That is our universe. We are one raisin, that distant galaxy is another, and the enormous quantity of expanding space between us has been carrying it away for the entire duration of its light's journey. Now add one more layer, the layer that makes it truly strange. Picture an ant crawling across that rising dough, trying to reach you, moving at a fixed, unchanging pace, its little legs, the equivalent of the speed of light. The ant is the beam of light from the distant galaxy. It sets out toward you at its top speed and never slows down. But the dough beneath it keeps rising, keeps stretching, so the distance the ant must cover keeps growing even as it crawls. If the dough rises slowly enough, the ant still gets to you, but the trip takes far longer than the original gap would have suggested, because it spent the whole journey fighting an expanding road. That is exactly what happened to the light we caught. It crawled toward us at the fixed speed of light for over 13 billion years, all while the space it was crossing kept stretching out ahead of and behind it. Think about what that does to a beam of light crawling toward us across billions of years. When this galaxy sent out its light, it was actually much closer to us than it is now, only about 2 billion light-years away at the moment of emission. But the instant that light set out, the space it had to cross began to stretch. Mile by mile, the road lengthened beneath it, even as the light raced forward along it. The light was moving toward us at its fixed absolute speed, and yet the distance it had to cover kept growing as it travelled, because new space kept unfolding in between. So the trip took far longer than the original 2 billion light-year gap would suggest. It took more than 13 billion years, because the finish line kept receding while the runner ran. It is worth slowing down on that emission distance, because it is the number people find hardest to believe. At the moment this galaxy released the light we now hold, it was only about 2 billion light-years from the place where the Earth would one day be. 2 billion, not 13, and certainly not 33. In the young, compact universe, everything was closer, so the galaxy was practically a near neighbour by cosmic standards when it sent its light on its way. The reason the trip still took more than 13 billion years is that the expansion kept lengthening the road faster than the 2 billion light-year head start would suggest. The light had a relatively short distance to cover at the start, but the finish line kept sliding away, so the crossing dragged on for age after age. 3 different numbers, then, describe this single galaxy. 2 billion light-years is how far it was when the light left. 13.5 billion is how long the light travelled. And 33 billion and more is how far away it sits now. All 3 are correct. They simply answer 3 different questions in a universe where the distances themselves refuse to hold still. And here is the part that truly bends the mind. During all those billions of years, the galaxy that emitted the light was being carried away from us by that same expansion. By the time its light finally reached us, the galaxy had been swept out to more than 33 billion light-years from here. So the number 13 billion describes how long the light travelled. The number 33 billion describes where the source is now. They are answers to 2 different questions, and in an expanding universe, those answers do not match. Light-years travelled and current distance are simply not the same thing, and the gap between them is nothing less than the growth of the universe itself made visible. There is a consequence of this that sounds like it should be forbidden. That galaxy, right now, is moving away from us faster than the speed of light, not through space. Nothing is racing through space faster than light, and nothing ever will. But the space between us and that galaxy is expanding so much, summed over such an enormous distance, that the total recession outruns light itself. This breaks no law of physics. The rule that nothing can exceed the speed of light governs motion through space. It says nothing about how fast space itself can stretch, and on the largest scales, space stretches faster than any beam of light could ever hope to cross it. This is the point where a lot of people feel a flash of resistance, a sense that they are being tricked with words, and I want to honour that feeling rather than brush past it. It genuinely sounds like a contradiction. Nothing outruns light, and yet the galaxy outruns light. The resolution is not a loophole or a technicality. It is that the rule you learned, the cosmic speed limit, is a rule about motion through space. It says that no object can move through space, past its neighbours, faster than light. and nothing here violates that. The distant galaxy is not rushing through its local space at all. It is sitting more or less still relative to the matter around it, just as we are sitting more or less still relative to ours. What is growing is the space in between, the enormous accumulated stretch of billions of light years of expanding cosmos, and there is no law anywhere that limits how fast space itself can grow. The speed limit governs the raisins, not the dough. And the dough, given enough of it, can carry 2 raisins apart faster than any beam of light could ever bridge them. Sit with that for a moment, because we are now standing at the edge of the truly unsettling part. The light we are receiving is old news, a message from a source that has since been carried impossibly far away, faster than light can follow, which means the connection we feel when we look at that orange point, the sense that we are seeing it, that it is there, that we are somehow in touch with it, is an illusion built entirely out of ancient light. We are not seeing the galaxy. We are seeing a ghost of it, 13 billion years stale, sent by a source that has long since receded beyond any hope of contact. And that raises the question that turns wonder into something colder. If this is only the past, only a snapshot, only a message from a place that has since fled beyond our reach, then what has become of the real thing, and why can we never, ever find out? Part 8. The snapshot is already gone. We need to be honest about what we are actually looking at when we look at that faint orange point, because it is not what it feels like. It feels like a window. It feels like we are gazing across space at a galaxy that is there, right now, doing whatever galaxies do. But that feeling is false in a way that becomes almost frightening the longer you hold it. We are not looking at the galaxy. We are looking at a single, frozen frame of it, taken more than 13 billion years ago, and that frame is all we will ever have. Consider what that means. Everything we can see of this place, every detail in that image, every fact we can measure about it, describes a moment that ended more than 13 billion years in the past. The galaxy did not stop when it sent out that light. It kept going. It kept living. Stars kept forming and dying. The galaxy grew, or merged, or transformed in ways we cannot know. All of that continued, chapter after chapter, for over 13 billion years. But not one page of that latest story is available to us. The only frame we possess is the first one, the one that happens to have finished its long journey to our eyes. There is a version of this that applies, quietly, to everything you have ever seen in the sky, and it is worth making explicit so the feeling generalizes. You have never once seen a star as it is. You have only ever seen stars as they were, each at its own depth of the past. Some of the stars you can see tonight may not even exist anymore, having died in the years or centuries since their light set out, and yet they still shine in your sky, ghosts kept alive by the travel time of their own light. The sky is not a live broadcast. It is a recording, assembled from footage shot at 1,000 different moments, all arriving together and pretending to be now. For the nearer stars, the delay is small, and the recording is nearly current. For this distant galaxy, the delay is 13 billion years, and the recording is almost the oldest it could possibly be. But it is the same effect, only taken to its limit. When you truly absorb that, the night sky quietly transforms from a window into the present to a museum of the past, every exhibit lit by ancient light. Imagine holding a single photograph of a person, taken when they were a small child, and understanding that this photograph is the only thing you will ever be permitted to see of them, not because they died. They did not die. They grew up. They lived an entire life. They are somewhere out there right now, changed beyond recognition. But you are frozen with the infant picture forever, and every road to any later image has been permanently closed. That is our exact relationship to this galaxy. We hold the picture of its earliest childhood, and the door to everything that came after has been shut and sealed. Sit with the strangeness of that arrangement, because it is unlike any separation you know from ordinary life. When someone moves to the far side of the world, they are distant, but their present is still, in principle, reachable. You could call them, or fly to them, or at least know that the same moment you are living, they are living too, and that a message sent now would find them soon. The separation from this galaxy is nothing like that. It is not that the present is far. It is that the present is unreachable, walled off, not by distance you could cross, but by the structure of space and the finite speed of light. There is no call you could place, no ship you could send, no message that would ever arrive, because the road between here and its present grows faster than any signal can travel it. The only version of that place you are permitted to know is the one that finished existing 13 billion years ago, and no effort, no patience, and no technology will ever change that. And it is worse, in a way, than simply not having the later pictures yet. It is not that we are waiting for them to arrive. The light that would show us this galaxy, as it is now, or even as it was 1 billion years after our snapshot, is still crossing the gulf between us, and because of the relentless expansion of space, much of it will never complete the trip at all. The universe is stretching the road faster than that newer light can travel it, so the later chapters of this galaxy are not merely delayed. Many of them are, for us, permanently unreachable, cut off by the geometry of an expanding cosmos. We are not early to the story. We are locked out of everything but its first line. Let me put it as plainly as I can. The place you are looking at is real, and it is a single frame from a time that no longer exists. Both halves of that sentence are true, and together they are the source of the quiet dread underneath this whole subject. You are seeing something genuine, not a fantasy, not a simulation, an actual galaxy that actually existed. And yet everything about the version you can see is finished. Over 13 billion years gone, while the real thing has moved on into a present state that is sealed away from you behind a wall of expanding space and unarrived light. And there is a further turn of the screw, one that makes the separation feel less like distance and more like fate. Even if we could somehow build a ship that travelled at very nearly the speed of light, and even if we were willing to send it on a journey lasting longer than the current age of the universe, it could never catch up to that galaxy. The expansion of space would carry the destination away faster than the ship could ever close the gap, the road unspooling ahead of the traveller faster than any traveller could run it. This is not a matter of insufficient technology or insufficient patience. There is no engine, no fuel, no century of waiting that would ever put a human hand on that place. It has passed beyond not just our sight, but our reach, permanently, by the geometry of the cosmos itself. We are separated from it by something far more absolute than distance. We are separated from it by the shape of space and the direction of time. Follow one of those particles of light for a moment, just to feel the weight of it. A single wave of light leaves this galaxy when the universe is young. It sets out toward a region of space where one day the Earth will form, though nothing like the Earth exists yet. For 13 billion years it travels, and the whole time the space beneath it stretches, drawing its wavelength longer, reddening it, tiring it, while its home galaxy slides ever further behind. Whole cosmic ages pass while it flies. The first stars die out. Galaxies mature. Our own galaxy forms. The sun ignites. The Earth cools and gathers oceans. Life begins, crawls, complicates, and eventually looks up and builds a telescope, and hauls that telescope out to a cold point 1,000,000 miles from home, and opens its golden mirror at exactly the right moment to catch this one ancient wave of light as it completes its journey. Consider how many ways that arrival could have failed, and how narrow the successful path was. For 13 billion years, that beam of light was on a collision course with a spot of space where, eventually, a telescope would happen to be. But there was no telescope for almost all of that time, and no Earth and no life. The light did not aim itself at us. It simply spread outward from its source in all directions, an expanding shell of ancient glow, and the overwhelming majority of it flew off into regions where nothing would ever catch it and is flying still, and always will be, unseen. Only the tiniest sliver of that galaxy's light, the fraction aimed at precisely our patch of sky, at precisely the right moment, arrived at a place where a watching eye had been built in time. Every other direction, every slightly different moment, and the light passes on into the dark, its message undelivered. When you look at that orange point, you are receiving one of the rarest things there is, a signal that beat astronomical odds simply to be noticed at all. The sender is gone, unreachable, carried beyond the horizon, but the message arrives. And we, the accidental recipients, read it and call it the most distant place we know, without quite admitting that what we are really holding is a letter from someone we can never write back to. Notice what kind of fear this actually is, because naming it correctly is the first step toward making peace with it. It is not the fear of something coming for you. Nothing about this galaxy threatens you in any way. It cannot reach you any more than you can reach it. The unease it stirs is subtler, and, in a sense, more profound than ordinary fear. It is the vertigo of confronting a limit that no cleverness can overcome, a wall built not out of danger, but out of the very fabric of space and time. We are used to limits that yield. Build a faster ship, a better tool, a bolder plan, and most walls eventually come down. This one does not. It is the rare kind of limit that is absolute, woven into the structure of reality itself, indifferent to every effort we could ever make. And standing before a limit like that, feeling how completely it cannot be crossed, produces a specific and unfamiliar chill. It is the feeling of meeting, perhaps for the first time, something the universe will simply never let us have. That is the terror the title promised, and it is not the terror of monsters or danger. It is the terror of separation, of permanence, of a distance that is not merely large but final. And if you think that this galaxy, at least, marks the true outer edge of things, the far wall of the universe, I am afraid the truth is stranger and more humbling than that, because this is not the edge. There is no edge here at all. Part 9. The edge that is not an edge. It is tempting to think of this most distant galaxy as sitting at the boundary of the universe, like the last house before the road runs out. It feels that way. It is the farthest confirmed thing we can see, so surely it must be near the limit of what exists. But that instinct is wrong, and understanding why it is wrong is one of the most quietly staggering ideas in all of cosmology. There is indeed a limit to what we can see, and it is real. We call it the edge of the observable universe. But notice that careful word, observable. It is not the edge of the universe. It is the edge of the part we are able to observe, and those are completely different things. The observable universe is not a region that ends because space ends. It is a region that ends because light runs out of time. Here is the reason. The universe has a finite age, a little under 14 billion years. Light travels fast, but not infinitely fast. So there is a maximum distance from which light could possibly have reached us in the entire history of the cosmos. Light from anything beyond that distance simply has not had enough time to arrive yet. There has not been enough universe, time-wise, for it to complete the trip. Because of the stretching of space, that maximum distance works out to about 46 billion light-years in every direction. That sphere, roughly 46 billion light-years in radius, is the observable universe. It is everything we can, even in principle, ever see. But there is no reason whatsoever to think the universe stops at that sphere. The boundary is not a wall of space. It is a horizon, and horizons are creatures of the observer, not of the land. When you stand on the ocean and see the horizon a few miles out, you do not believe the sea ends there. You know perfectly well that the water continues far past what you can see, and that the horizon only marks the limit of your particular vantage point. Walk forward, and the horizon moves with you. It is not a place. It is a relationship between you and the curve of the world, and it belongs to you alone. Another person standing a mile away has their own horizon, centered on themselves, and the two do not coincide. There is no single true horizon that everyone shares, because a horizon is not a feature of the sea at all. It is a feature of looking. The edge of the observable universe is exactly that kind of thing, only built from the age of light instead of the curve of the earth. It is centered on us, because we are the ones doing the looking, and every other observer in the cosmos has their own version, centered on themselves, reaching the same distance in every direction, but enclosing a different sphere of space. There is no universal edge that everyone agrees on. There is only your horizon and mine, and that distant galaxies, each of us sitting at the center of a bubble defined by how far light has had time to travel since the beginning. To mistake that horizon for the edge of reality is exactly like standing on a ship and concluding that the ocean stops where your eyes give out. The edge of the observable universe is exactly that kind of boundary. It marks how far our light gathering has reached, not how far the world goes. There is an even subtler point hiding here, and it deepens the strangeness rather than resolving it. Because the universe is not only expanding, but expanding at an increasing rate, the horizon is not simply going to keep opening up to reveal more and more forever. In the very long run, the accelerating expansion means that distant galaxies are being carried away so quickly that their light will eventually fail to reach us at all. And one by one, over immense spans of time, the far galaxies will redden and dim and slip permanently beyond view. The observable universe in that sense is not only bounded, it is in the extremely slow process of emptying. What we can see is, on the grandest timescale, a shrinking inheritance. We happen to live in an era when a great deal is still visible, when the sky is still full of other galaxies whose light can still complete the trip. Future observers, unimaginably far in the future, may look out and see almost nothing beyond their own galaxy, the rest having receded into permanent invisibility. We are, in a strange way, lucky to be looking now. Beyond that horizon, the honest answer is that we do not know what lies there, but we have every reason to believe it is more of the same. More galaxies, presumably billions upon billions of them, more of the structures we recognize, stretching on past the limit of our sight. Some models suggest the universe might be enormously larger than the part we see, so much larger that our entire observable sphere is a single grain in a beach we can never survey. Other models go further still and suggest the universe may simply be infinite, going on without end in every direction, containing an endless supply of galaxies we are forbidden to ever detect. And if the universe truly is infinite, the consequences become almost too strange to state plainly, though they follow with a kind of cold logic. In an endless universe, filled, on average, with the same kinds of things everywhere, there would be no limit to how much exists. There would be an infinite number of galaxies, an infinite number of stars, an infinite number of worlds. And with infinite worlds and only a finite number of ways to arrange matter on any one of them, some patterns would have to repeat. Somewhere out there, unfathomably far beyond our horizon, there might be regions almost identical to our own, and even, if you push the logic to its limit, places nearly indistinguishable from the room you are resting in right now. This is speculation piled on speculation, and I offer it as a possibility rather than a fact. But it is the kind of possibility a genuinely infinite universe quietly opens up. And every bit of it, every last one of those endless worlds, would lie forever outside the little sphere of space whose light has had time to reach us. The window would not just be smaller than the world. It would be infinitely smaller, a single lit room in a house with no walls and no end. We can even say something about the true size of things, at least at the lower end, and the numbers are humbling. By carefully measuring the overall shape and curvature of the space we can see, and finding it astonishingly flat, cosmologists can set a floor on how much bigger the whole universe must be than the part we observe. That floor is not modest. The evidence suggests the entire universe is, at the very least, hundreds of times larger across than our observable bubble, and quite possibly enormously more than that. Some serious analyses put the minimum at many times our horizon in every direction, meaning that for every galaxy we can see, there are immense reaches holding countless galaxies we never will. And that is only the floor. The smallest the universe is allowed to be given what we measure. The ceiling may be infinite. We are not looking at a large fraction of reality with a bit hidden at the edges. We may be looking at a rounding error, a single visible grain in something without any end at all. So consider the position we are actually in. That most distant galaxy, the one we have been calling the edge, is not near any edge at all. It merely happens to sit close to the farthest point our light has managed to reach in the time available. It is not the last thing. It is only the last thing we can see. And past it lies not a wall, not a void, not an ending, but almost certainly an unimaginable extent of universe that will remain forever outside our window. The window is smaller than the world. That is the plain truth of our situation, and it is worth saying slowly. Everything we can ever observe, every galaxy, every star, every distant orange point, all of it fits inside a bubble, defined not by the size of reality, but by the age of light. And reality does not care about the size of our bubble. It extends past it, indifferent, uncounted, unseen. This is a strange kind of humility to absorb. We are not looking at the universe when we map the sky. We are looking at the portion of the universe whose light happened to reach us in time, a portion that grows a little each year as more distant light completes its journey, but a portion that will always be a fraction, possibly an infinitely tiny fraction, of the whole. The most distant place we know is a marker not of where the universe ends, but of how far our vision has managed to crawl. And once you understand that, the faint orange point takes on yet another layer of strangeness, because it is not just old and not just unreachable, it is also, in the most literal sense, still out there. Part 10. It is still there. Of everything we have talked about tonight, this is the idea I find hardest to hold in my head, and the one that stays with me longest after the telescope is put away. That galaxy still exists. Right now. This is not a fossil we are studying, not a remnant, not a thing that lived once and is gone. It is a place that is out there in the present universe, at this very moment, being something, and we will never know what. Let me try to make that concrete. When we look at the snapshot, we see the galaxy as it was 290 million years after the beginning. But more than 13 billion years have passed there since that light departed. 13 billion years is not a number the mind can really absorb, so let me anchor it. It is roughly 3 times as long as the Earth has existed. Everything that has ever happened on this planet, the formation of the oceans, the first life, the slow climb from single cells to fish to forests to us, all of the history of our entire world, has taken about 4 billion years. This galaxy has had more than 3 times that span to keep changing since the moment we see. Let me try to make 13 billion years feel like something other than a number, because the number alone slides right off the mind. Suppose you tried to count those years, 1 per second, never sleeping, never stopping. You would not finish in your lifetime. You would not finish in 1,000 lifetimes. You would still be counting long after your civilization had risen and fallen and been forgotten. That is the gap between the snapshot we hold and the present of that galaxy. And it is not a pause. It is not a held breath. It is the single longest stretch of active, ongoing change that the universe has ever run, and all of it has happened at that location while we sat here holding the one early frame. Whole eras of that galaxy's life have come and gone. If it has stars with worlds, those worlds have had time to form, to cool, to weather, perhaps to gather oceans and lose them again, perhaps to give rise to something and then outlive it many times over, in the time we have been staring at its infancy. So, what is it now? Almost certainly, it is nothing like the young, chaotic, blazing thing in our image. 13 billion years is enough time for a galaxy to transform completely. It may have grown vastly larger. It may have merged with neighbours, swallowing them and being reshaped in the collision. It may have quieted from its furious early star-making into something calmer and more settled, the way our own galaxy has. It may by now be full of stars with planets, worlds of rock and water and air, assembled from the heavy elements that all those early exploding giants seeded into the surrounding space. The building blocks were already there, already unusually abundant, all those billions of years ago. Given the time it has had since, it would be strange if nothing settled and cooled and gathered into worlds. To feel the force of that, hold the two timelines side by side. On Earth, it took roughly 4 billion years for life to travel the whole distance from the simplest single cells to a creature that could grind a mirror, coat it in gold, launch it into space, and use it to read the chemistry of the dawn of time. 4 billion years, from pond scum to astronomy. That is the pace at which a world can go from lifeless chemistry to a mind that studies the cosmos, given a stable planet and a steady star. Now set that against the more than 13 billion years that have passed at this distant galaxy since the moment we see. That is enough time to run the entire Earth story from scratch, not once but 3 times over, with billions of years to spare. If life is anything other than a one-time fluke unique to our single planet, then a place with that much time, and that early an abundance of the elements life is built from, has had every opportunity the universe knows how to give. And I will go one step further, and I will mark it clearly as speculation, because this channel does not sell guesses as facts. Given more than 13 billion years, given an early abundance of the very elements that life on Earth is built from, it is not unreasonable to wonder whether that place now holds something that observes, that thinks, that questions the sky the way you are doing right now. Life on our world took about 4 billion years to go from the simplest cells to a creature capable of building a telescope and pointing it at the dawn of time. That galaxy has had more than 3 times as long. Whether anything is there, we cannot say. But the raw ingredients, the time, and the opportunity are all present in abundance. It is, at the very least, not a foolish thing to imagine. And here is a thought that I find quietly staggering every time I return to it. Right now, as you lie there listening, that galaxy is doing something. This is not a figure of speech. In the real, present universe, at this exact moment, more than 33 billion light-years away, that place exists and is undergoing whatever it is undergoing. Stars are being born or dying there tonight. Something is happening there right now, in the same now that you occupy, the same present tense in which you are breathing. We tend to file distant cosmic things away, as though they belong only to the past, because the past is all we can see of them. But that is a trick of our vantage point. The galaxy is not a historical artifact. It is a contemporary. It shares this instant with you, even though neither of you can ever confirm the other's now. You and that ancient, unreachable place are, in the most literal sense, alive at the same time. Here is the part that turns wonder into a kind of ache. Whatever that galaxy has become, whatever exists there now, we are completely and permanently cut off from it. The light that would show us its present state either has not arrived or, because of the expansion of space, never will. For us, This place is frozen forever in its infancy, a single image from a moment that ended before our planet was born, while the real thing, the living present of it, continues somewhere out there entirely beyond our reach. We know it is there. We can point to the direction. We can even calculate roughly where it is now, more than 33 billion light-years away, and we can never, ever see it. Not with a better telescope, not with more patience, not ever. The blindness is not a limit of our technology. It is built into the shape of the universe itself. That, to me, is the real weight the title was reaching for. Not fear of the place, but the strange grief of it. There is a real, existing world out there, possibly teeming, possibly watching its own sky, and the universe has arranged things so that we may hold only its baby picture and nothing more, forever. The distance between us, and it is not a distance you could cross with enough time or a fast enough ship. It is a distance woven into space and time so thoroughly that no amount of either can undo it. We are separated from the present of the most distant place we know, not by miles, but by the very structure of reality. And once that lands, it changes how you feel about your own place in all of this, because the situation is not one-sided. It cuts both ways. Part 11. We are someone else's distant galaxy. Turn the whole thing around for a moment. We have been standing here, on the Earth, at the receiving end, looking out at a faint orange point and marvelling at how far and how old and how unreachable it is. But there is nothing special about our vantage point. The universe does not have a centre, and it does not have a privileged observer. So flip the telescope. Imagine you are standing not here, but there, somewhere in that distant galaxy, at some later moment in its long life, looking back toward us. This is not a trick of perspective or a poetic flourish. It is a straightforward consequence of the fact that the physics works the same everywhere. There is no special observer in the universe, no privileged spot from which everything looks current and complete. The laws that make us see distant things only in their past are the same laws that operate at that galaxy and at every galaxy and in the empty space between them. So the situation is perfectly, mercilessly symmetric. We hold their baby picture, and if anything there is looking, it holds ours. Neither of us can ever reach the other's present. Neither of us is special. We are two islands of now, each visible to the other only as we used to be, each forever locked out of the other's real, current existence. What would you see, looking in our direction? You would not see the Earth, of course, and you would not see the Sun, and you would not see the Milky Way as it is now. You would see, if you had a telescope as fine as ours, a faint reddish smudge, ancient and stretched, a single frame from our own distant past. You would be looking at our galaxy as it was billions of years ago, or you might see nothing of us at all, because our light, too, has to cross an expanding gulf, and much of it would never reach you. To an observer out there, we are the distant, unreachable, frozen snapshot. We are the faint orange point that looks like it might be a flaw in the sensor. We are the most distant place, seen only as we once were, our present sealed away from them, exactly as their present is sealed away from us. And notice that this is not a special disability of ours, not some limitation of our particular technology or our particular corner of space. It follows directly from two facts that hold everywhere in the universe. Light travels at a finite speed, and space is expanding. Put those two together, anywhere, for any observer, and you get the same result. Every observer sees the distant universe only in its past. Every observer sits at the center of a bubble of visibility bounded by the age of the cosmos. Every observer is, to sufficiently distant watchers, only an ancient image. There is no vantage point anywhere. No matter how advanced the civilization, no matter how perfect the instrument, from which the universe can be seen whole and current, all its distant places, shown as they truly are at this moment. That view is not merely beyond us, it is beyond anyone. It does not exist and cannot exist. The present state of the distant universe is not a secret being kept from humans. It is a thing that no observer of any kind in any location is permitted to have. This is the symmetry that I find, in the end, strangely comforting, though it starts out as one more dizzying blow. Every observer, anywhere in the universe, is in precisely the same situation we are. Each one sits at the center of their own observable bubble. Each one sees the distant universe only as it was, never as it is. Each one is, to everyone sufficiently far away, nothing but an old image, a message from the past, a place that can be seen but never reached. There is no observer anywhere who gets to see the universe as it truly is, all at once, in a single, honest present. That view does not exist for anyone. It is not that we are uniquely blind. Blindness to the present of distant things is simply the condition of existing inside an expanding universe where light takes time to travel. Everyone is in the dark about everyone else's now. I find it helps to imagine the whole cosmos as a great, slow conversation in which everyone is always speaking to everyone else's past. Every galaxy is broadcasting itself outward in light, endlessly in all directions. And every galaxy is receiving the ancient broadcasts of all the others, each one delayed by the time its light took to arrive, so that what any observer sees is never the current chorus, but a layered arrival of old songs, the nearer voices only slightly behind, the farther ones reaching back toward the beginning. No one in this conversation ever hears anyone else as they are now. Everyone hears everyone else as they were. And yet the conversation is real. The light truly arrives. The connection, though stretched across impossible gulfs of time, is not imaginary. We really are in contact with that distant galaxy, just not with its present. We are in contact with its past, and that is the only kind of contact the universe permits between things this far apart. There is something almost tender in that arrangement once the initial vertigo passes. It means the early universe is not sealed off from us in a closed vault. It is still speaking, still sending its oldest light across the widening dark, and we are still receiving it, night after night, if we build the instruments to listen. The past is not gone, it is in transit, and every clear observation of a distant galaxy is a moment when the ancient past of the cosmos touches the present of a small, curious species that only recently learned how to catch it. That is not a story of isolation. It is a story of an unbroken thread of light connecting the beginning of everything to a mind capable of noticing. And so the loneliness of it inverts, quietly, into a kind of kinship. Yes, we are cut off from the present of that distant galaxy. But that galaxy, and every possible watcher within it, is cut off from ours in exactly the same way, by exactly the same physics. We are not alone in our separation. We are all separated together, every observer in the cosmos holding old photographs of every other, each of us a letter the others can only ever read long after it was written. The whole universe is one enormous correspondence conducted across such immense delays that no two distant parties can ever be in the same moment at the same time. When you look at that orange point and feel the ache of not being able to reach it, you can also know that somewhere, perhaps, something is looking back toward the faint smudge of us and feeling the very same thing. There is even a gentle humility in the symmetry that I think is worth naming before we let it go. For most of human history, we imagined ourselves at the center of things, with the heavens arranged around us as spectators around a stage. One discovery after another has quietly dismantled that picture, moving us off the center, showing us to be one world among many, one star among billions, one galaxy among trillions. And this is perhaps the final turn of that long lesson. We are not even privileged in what we can see. Our view is not the true view, not the complete view, just one local vantage among countless equivalent others, each as partial and as past-bound as ours. That could feel like a demotion, but there is a freedom in it too. We are not burdened with being the center. We are simply one of the countless places from which the universe looks at itself, each seeing a little, none seeing all. Every one of us, a small window through which the cosmos briefly becomes aware of its own enormity. That reframing does not erase the strangeness. It should not. But it does something to it. It takes the cold fact of cosmic separation and reveals, underneath, a structure that every conscious thing in the universe must share. We are not the only ones marooned on an island of the present, able to see other islands only as they used to be. That is simply what it is to look out into a universe like this one. And it means that the vertigo you feel, the sense of being small and cut off and unable to touch the most distant places, is not a private curse. It is the universal experience of anyone, anywhere, who ever looks up. Which brings us, gently, to the question of what to do with all of this. How do you live comfortably under a sky that is mostly unreachable, mostly past, and mostly invisible? I think the answer is softer than the fear suggests. Part 12. The comfort in the unreachable. We have walked a long way tonight, from a faint orange point that looks like a smudge, all the way out to the structure of the observable universe and back to our own small place inside it. And I want to end not on the fear the title promised, but on what lies just underneath that fear, because I think that is where the real feeling lives. The terror, when you turn it over slowly, has a calmer thing hidden inside it. And it is worth uncovering before you drift off. Yes, the most distant place we know is unreachable. Yes, we see only its past and never its present. Yes, it is not even the true edge of anything, only the limit of our vision, with an unimaginable extent of universe lying forever beyond our window. Yes, the window is smaller than the world, and always will be. Every one of those facts, taken alone, can feel like a kind of diminishment, as though the universe has drawn a series of walls around what we are allowed to know, and left us small and blind at the center. And if you stop there, it is a bleak picture. But there is a way of holding all of it that turns the weight into something you can actually carry, and it begins with noticing what kind of creature could even be troubled by these facts in the first place. A rock is not disturbed by the size of the universe. A river does not feel small beneath the stars. To be unsettled by cosmic distance, you have to be the sort of thing that can hold a galaxy in your mind, that can measure a distance you will never cross, that can imagine a present you will never see and feel the ache of missing it. The very capacity to be frightened by the scale of the cosmos is itself one of the rarest and strangest things the cosmos has produced. The fear is not a sign of your smallness. It is a sign of the improbable largeness of what you are, that a brief arrangement of atoms on one small world can take in the whole sweep of space and time and be moved by it. But look again at what we actually did. A creature made of the scattered ashes of dead stars, living on a damp rock for a cosmic instant, managed to build a machine, carry it out into the cold, and catch a single wave of light that had been travelling since before its planet existed. And from that faint, stretched, exhausted whisper of light, it read the distance, the age, the size, the very chemistry of a galaxy at the dawn of time. We were not there. We can never go there. We cannot even see its present, and yet we know it exists. We know roughly what it was, and we know, astonishingly, that it is still out there right now, changing in the dark. That is not a story of blindness. That is a story of sight, so far beyond what any creature has any right to possess, that it borders on the miraculous. There is a quieter reassurance folded into the mystery too, and it has to do with continuity rather than reach. When you look at that faint orange point and understand that it is still out there, still changing, still going, you are being handed a strange kind of permanence. The universe did not flare up at the beginning and then settle into a finished stillness. It is still in motion, still building, still writing new chapters at that distant location and at countless others, right now, whether or not anyone is there to see. The story is not over. The most distant place we know is not a closed book from a dead past. It is an open one, its later pages being written at this very moment, in a hand we cannot read, but can be certain is still moving. There is something steadying in that, something that pushes back against the loneliness. We are not the last witnesses of a universe winding down. We are early witnesses of a universe still very much underway. The unreachability, I have come to think, is not an insult. It is an invitation. If we could see everything, all at once, with nothing hidden and nothing delayed, there would be no horizon left to wonder about, no distant frame to puzzle over, no sealed present to imagine our way toward. The very fact that the window is smaller than the world is what leaves room for wonder in the first place. A universe we had completely mapped would be a universe with nothing left to reach for. Instead, we have been given something better, something endless, a cosmos that always extends past the edge of what we can see, forever offering one more faint point of light, just barely within our grasp, and countless more beyond it that we will never touch. The smallness of the window is exactly what makes the world worth looking at, and if the unreachability still sits heavy, try holding it beside the alternative, because the alternative is worse. Imagine a universe small enough to see all at once, a universe you could survey completely, every corner known, every distance crossed, nothing left beyond the horizon because there was no beyond. It would be a finished thing, a closed room with all the lights on, and after the first careful look there would be nothing left to wonder about, nowhere left to point the telescope with any real hope of surprise. The endlessness that makes us feel small is the very same endlessness that guarantees there will always be one more thing to find, always a fainter point of light, just at the limit of our reach, always a question the sky has not yet answered. A universe you could fully hold would be a universe you could exhaust. This one, mercifully, we never can. And there is a final gentleness in all of this, one I hope you carry with you as you rest. When you look at that ancient orange point, you are not only looking at something impossibly far and impossibly old, you are looking at the beginning of the very process that led to you. Those early blazing short-lived stars, forging the first heavy elements and scattering them into space, were doing the work that would eventually, across billions of years and countless generations of stars, build the carbon and oxygen and iron that make up your body. That distant galaxy, and others like it, are not strangers. They are ancestors. The most distant place we know is a picture of the kind of furnace where the atoms of your own hand were first cast. To look at it is, in a strange and literal way, to look at where you came from. Notice, as you drift towards sleep, how far we have travelled from where we began. We started with a faint orange dot that looked like a flaw in the sensor, the kind of thing you would wipe off a lens without a second thought. And by following that dot patiently, one honest step at a time, we ended up here, holding the age of the universe, the stretching of space, the limits of sight, and our own origins, all folded into a single point of ancient light. That is what this channel is really about, in the end. Not the fear, though the fear is real and worth feeling. It is about the fact that the plain, faint, easily overlooked things in the sky turn out to contain, when you look closely enough, the whole story of everything, including you. The most ordinary-looking smudge in a picture was a doorway into the beginning of time, and all we had to do was refuse to look away, so let the fear soften into something closer to belonging. The universe is unimaginably larger than we can ever see, and most of it will remain forever beyond our reach. But the small, glowing fragment we can see is enough to have shown us our own origins, enough to have taught us that we are made of the same ancient light we are gazing at, enough to fill a quiet night with more wonder than a single mind can finish holding. The most distant place is still out there, right now, doing whatever it is doing, forever unknown to us. And we are here, briefly, made of the same stuff, looking out at it across everything, and understanding just enough to feel how remarkable it is that we can look at all. That, in the end, is not a terrifying thought. It is the most reassuring one I know. Rest well, and let the old light keep arriving while you sleep.